Imagine waking up one morning to find your world plunged into chaos. No electricity, no internet, no satellite communication. Could this be the result of a cyber attack, a natural disaster, or something else? Welcome to the world of solar flares. A sudden flash of increased brightness on the sun, a phenomenon so powerful it can disrupt the rhythm of our modern lives. These flares are a natural occurrence, but their potential to wreak havoc on our technology-dependent society is anything but ordinary. Consider the sun as a celestial body constantly bubbling with energy. At times, this energy is released in the form of solar flares, akin to cosmic hiccups, only far more potent. These flares can send a torrent of high-energy particles hurtling towards Earth. On a good day, our planet's magnetic field shields us from this solar onslaught. But what happens when the sun burps out an exceptionally powerful flare? To understand the potential havoc, we need to rewind the clock to the late summer of 1859. This was the year of the Carrington event, named after the British astronomer Richard Carrington, who first observed this colossal solar flare. This event saw telegraph systems across Europe and North America fail, with some reports of operators receiving electric shocks from their equipment and paper catching on fire. Now consider the fact that this was in an era when our dependency on electronics was minimal. Imagine what could happen today with our lives so intertwined with technology. Our banking systems, communication networks, power grids, and even our vehicles rely heavily on electronics. A solar flare of the scale of the Carrington event could potentially send us back to the Dark Ages, quite literally. But let's not let our imagination run too wild. After all, we've come a long way since 1859. And we've developed technologies to predict and prepare for such events. So the real question is not whether a solar flare could cause chaos, but how prepared are we for such an eventuality? So if a solar flare of similar magnitude were to hit Earth today, what would be the consequences? Stay tuned as we delve deeper into this celestial threat in the upcoming scenes. Imagine a world where the technological advances we take for granted are suddenly wiped out, a world where we are thrown back into the Dark Ages. Our world is a complex web of technology and infrastructure. The power grid, our communication systems, our transportation networks, all these are intricately linked and highly dependent on technology. Now imagine a powerful solar flare sweeping across this web, causing widespread power outages and satellite disruptions. Imagine the chaos as the lights go out not just in one city but across entire continents. The internet, our global nerve center, is knocked offline. Your mobile phone, your lifeline to the world, is rendered useless. The screens that rule our lives, from the televisions in our living rooms to the computers in our offices, are suddenly blank. But the impacts of a solar flare go beyond just our gadgets and devices. Our transportation systems would grind to a halt. Air travel would be severely disrupted, with GPS systems failing and air traffic control systems going offline. Our roads would be plunged into chaos as traffic lights fail and electric vehicles stop in their tracks. And then there are the potential health risks. A powerful solar flare could result in increased radiation exposure, leading to a range of health issues from skin burns to more serious conditions. But perhaps the most alarming impact of all would be on our food and water supply. With power outages affecting the operation of water treatment plants and refrigeration systems, clean water and fresh food could quickly become scarce. This is the potential aftermath of a powerful solar flare, a world where our dependence on technology becomes our downfall, a world where we are forced to confront our vulnerability and adapt to a new reality. Such a scenario is not merely the stuff of science fiction. It is a real possibility that scientists and researchers are actively studying. But how likely is such an event to occur, and what can we do to prepare? The possibility of a solar flare of such magnitude hitting Earth is not merely a science fiction scenario. It's a real threat that scientists have been warning us about for years. A solar storm of this intensity is a rare event, but it's not impossible. Based on historical data, we know that a solar superstorm occurred in 1859, known as the Carrington event. If such an event were to happen today, the consequences could be devastating. Our understanding of solar activity is constantly evolving. While we can't predict exactly when the next super flare will hit, scientists are working tirelessly to improve our forecasting capabilities. Just as we track hurricanes and other natural disasters, we have the potential to advance our tracking of solar storms. With better prediction, we can give ourselves a fighting chance to prepare and protect our technology. But how do we prepare for such a catastrophic event? The answer is multifaceted and involves both individual and societal measures. On a personal level, having an emergency plan and supplies in place is crucial. This includes basics like food, water, and medical supplies, but also means considering how you would cope without electricity for an extended period. On a larger scale, societies need to invest in robust infrastructure that can withstand the electromagnetic onslaught of a solar superstorm. This means hardening our power grids, protecting our satellites, and developing technology that can function even in the face of such an event. It's not just about surviving the initial impact, but also about ensuring we can recover and rebuild in the aftermath. Investing in research and development is also key. We need to understand more about our sun and its behavior if we are to mitigate the risks posed by solar flares. This is a global issue that calls for international cooperation and collaboration. While we cannot prevent a solar flare from occurring, we can take steps to mitigate its impacts, ensuring that we are not left in the dark.